Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve the systems equation by elimination. Now, you might look at this and say, well, I think this might be easier to do by substitution. And yes, you can solve it by substitution as well. But for this video, we're going to do it by elimination. So to do that, we got to get the coefficients to be the same. And preferably, we only want to multiply by one multiplier if we can help it. So you see, to get these to be the same, we got to find our common denominator of 5 and 2, which would be 10. But then you have to multiply a multiplier on the top equation and the bottom equation. What I like about the eliminating the variable c is that here I have a coefficient of 1 and 3. So therefore, the common denominator, or the common coefficient, would just be 3. So now, to get them to be common, all I simply need to do is multiply my top by a multiplier of -3. I don't know why I wrote that line there. So when I multiply my top by -3, I get -3c. Oh, I guess I was maybe separate. I don't think. That's just too far away. So multiplying this through, we've got to make sure you multiply it by every single term to produce equivalent equations. I get -3c plus 15d equals 32, positive 48. Then I just take this equation and I put it back under. So I have 3c plus 2d equals -14. OK, so now, again, I just add my equations up. Because if I add them, then these are going to eliminate the c because they give me 0c, which is just 0. This becomes 17d. This becomes 34. Divide by 17, divide by 17, d equals 2. Now I know the value of d. I can plug that into this equation to solve for c. So you can use either equation that you want to. I'm going to use the top equation because I don't have to do anything else to c. So c minus 5d equals -16. Again, we now know the value of d. So c equals, c minus 5 times 2 equals -16. c minus 10 equals -16. Add 10, add 10, c equals -6. So there you go, ladies and gentlemen. Now the solution set is going to be 2, -6. Thanks.